Good afternoon, and welcome to Hand-Wavy Chemistry, where we do not delight in the details, but rather bask in the big picture. Today, it's problem time, where we answer chemistry questions either from old exam papers, popular web searches, or even those that have been submitted by you down in the comments section. Today, we're going to be looking at how an element's identity, its atomic number, its atomic mass number, and its charge are related to the number of protons, neutrons, and electrons it has. Let's start by considering an atom's identity and its atomic number. Both of these values are linked to the number of protons present. For example, hydrogen. All hydrogen atoms have one proton in the nucleus, and they have an atomic number of 1. Helium has 2 protons in the nucleus and has an atomic number of 2. Jumping ahead a little, you can say carbon. All carbon atoms have 6 protons in the nucleus. All atoms with 6 protons are carbon and have an atomic number of 6. Just like all atoms with 2 protons have an atomic number of 2 and are helium. It is the number of protons that determines an atom's identity. Neutrons are also found in the nucleus, and by adding the number of protons and neutrons together, we find the atomic mass number. The most common form of hydrogen actually has 0 neutrons. So its atomic mass number is still 1. Helium, in its most common form, has 2 neutrons. So adding the 2 protons to the 2 neutrons, we get an atomic mass number of 4. The most common form of carbon has 6 neutrons. Adding the 2 sixes together, we have an atomic mass number of 12. Another common form of carbon is carbon-13. It must still have 6 protons because all carbon atoms have 6 protons. However, now we must have an extra neutron because we have to have the 6 plus 7 that add to 13. So 6 protons and 7 neutrons, 6 plus 7, 13. The other part of an atom is the electron. Electrons are negatively charged. If an atom has the same number of electrons as it does protons, then it will have no charge. However, if there is a mismatch, then there will be a charge. If there are more protons than electrons, then it will be a positive charge. If there are more electrons than protons, it would be a negative charge. So in the case of this first hydrogen atom we have here, if we have 1 electron, there is no charge. However, if we were to have H+, that would have 1 proton, because all hydrogen atoms have 1 proton, and it would have no electrons. If we were to have something like F-, so fluorine minus, all fluorine atoms have 9 protons. And because there is a negative charge, there must be 1 more electron than there are protons. So there would be 10 electrons. These charged atomic species are known as ions. Now let's take these ideas and these concepts and apply them to some actual exam questions. In this question, we're asked which pair of atoms contains the same number of neutrons. So we're going to have to go through and do a quick calculation for each atom to determine the number of neutrons it has. Remember that the smaller number is the atomic number, and that identifies the number of protons in the nucleus as well as which element is present. So for the case of cobalt, we have, it says 59CO27. So we know there are 27 protons, and the overall atomic mass is 59. So if we do 59 minus 27, we will find that there are 32 neutrons. For the case of the nickel there, again, it's 59 Ni28. So we're going to do 59 minus 28. And this time, there's only 31 neutrons. So we know that this is not the right answer. Let's jump down to option C. In this case, we've got 64 and 29 for copper. So 64 minus 29 is 35 neutrons. For zinc, we've got 65 as the atomic mass number, 30 as the atomic number. We said that it was zinc. 65 minus 30, so there are 35 neutrons. This means that C here is the correct answer. I do hope you've enjoyed this video, and if you have, please make sure to like and subscribe and share it with your friends. If there are any topics you'd like to see covered in a future video, please make sure to put them down in the comment section. Thank you, and I hope you have a wonderful rest of your day.